Welcome to our lesson on significant figures. Significant figures, also known as significant digits, are an important concept in science and mathematics that helps us communicate the precision of our measurements and calculations. In this video, we'll learn what significant figures are, how to identify them, and the rules for using them in calculations. So, what exactly are significant figures? Significant figures are all the digits in a number that are known with certainty plus one digit that is uncertain or estimated. When we make a measurement, the significant figures tell us about the precision of that measurement. Let me show you what I mean. Now, let's learn how to identify significant figures in a number. There are several rules we need to follow. Rule number 1. All non-zero digits are always significant. For example, in the number 253, all three digits are significant because they are all non-zero. Similarly, in 7.82, all three digits are significant. Rule number 2, zeros that appear between non-zero digits are always significant. For example, in the number 503, the zero is between two non-zero digits, so it is significant. This number has three significant figures. Similarly, in 6.05, the zero is between two non-zero digits, so it is significant. This number also has three significant figures. Rule number 3, leading zeros or zeros at the beginning of a decimal number are not significant. They only serve to locate the decimal point. For example, in 0.005, the first three zeros are not significant. Only the 5 is significant, so this number has only one significant figure. In 0.023, the first two zeros are not significant. The 2 and 3 are significant, so this number has two significant figures. Rule number 4, trailing zeros or zeros at the end of a number are only significant if the number contains a decimal point. For example, in the number 200, which has no decimal point, the trailing zeros are not significant. This number has only one significant figure. But in 200.0, the decimal point indicates that the trailing zeros are significant, so this number has four significant figures. Similarly, in 300 point, the two zeros are significant because of the decimal point, giving us three significant figures. Rule number 5, in scientific notation, all digits in the coefficient are significant. For example, in 3.4 times 10 to the fourth, the coefficient is 3.4, which has two significant figures. In 5.00 times 10 to the negative 2, the coefficient is 5.00, which has three significant figures because the zeros after the decimal point are significant. It's important to note that some numbers are considered exact and have an infinite number of significant figures. These include defined quantities like 60 seconds in a minute, counted numbers like 3 apples, conversion factors like 2.54 centimeters per inch. For example, if we say there are 7 days in a week, the number 7 is exact and has an infinite number of significant figures. Now, let's look at how significant figures work in calculations. For addition and subtraction, the result should have the same number of decimal places as the measurement with the fewest decimal places. Let's look at an example. If we add 23.456 and 1.9, the result would be 25.356. However, since 1.9 has only one decimal place, our final answer should also have only one decimal place. So we round to 25.4. For multiplication and division, the result should have the same number of significant figures as the measurement with the fewest significant figures. Let's try an example. If we multiply 4.2 times 0.105, the result would be 0.441. 4.2 has two significant figures, and 0.105 has four. Since 4.2 has the fewest significant figures, 2, our final answer should have two significant figures. So we round to 0.44. When adjusting your answer to the correct number of significant figures, you need to follow these rounding rules. 1. If the first digit to be dropped is less than 5, round down. 2. If the first digit to be dropped is greater than or equal to 5, round up. For example, if we need to round 2.543 to three significant figures, we would drop the 3, leaving us with 2.54. If we need to round 2.543 to two significant figures, we would drop both 4 and 3, and since 4 is less than 5, we round down to 2.5. If we need to round 2.543 to one significant figure, we would drop 5, 4, and 3, and since 5 is greater than or equal to 5, we round up to 3. Let's look at a practical example of why significant figures are important. Imagine a scientist measuring the length of a rectangle as 7.45 centimeters and the width as 3.2 centimeters. To find the area, we multiply length times width. 7.45 times 3.2 equals 23.84 square centimeters. However, following our multiplication rule, we can only keep two significant figures in our answer because the width has only two significant figures. So the correct area would be 24 square centimeters. Let's summarize what we've learned about significant figures. 1. All non-zero digits are significant. 2. Zeros between non-zero digits are significant. 3. Leading zeros are not significant. 4. Trailing zeros after a decimal point are significant. 5. In scientific notation, all digits in the coefficient are significant. For calculations, in addition and subtraction, match the number of decimal places. In multiplication and division, match the number of significant figures. Significant figures are important because they tell us about the precision of our measurements and calculations, helping us communicate scientific results accurately.